Our lesson today about medians of triangle. First, what is the median of a triangle? A median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. If we have a triangle ABC and D is a midpoint of side BC, then the line segment AD is called a median of triangle ABC. Any triangle has three medians. Here we have a triangle ABC. The first one, which is in blue, is acute angle triangle, and the red one is right angle triangle, and the green is obtuse angle triangle. Any triangle has three medians. In acute triangle, there is three medians. In right angle triangle, also there is three medians. And in obtuse angle triangle, also there are three medians. We can note that the three medians meet at one point. The three medians are meeting at one point. Now we will study theorem 1. The medians of a triangle are concurrent. Here we have three triangles. The blue one is acute. The red one is right angle. The green one is obtuse angle triangle. As we said before, any triangle has three medians. Here, theorem told us that any triangle, whatever its type, the three medians meet at one point. In acute one, also in right angle, and also in obtuse angle triangle. Now we will study theorem 2. The point of concurrence of medians of the triangle divides each median in the ratio 1 to 2 from its base, or 2 to 1 from the vertex. What we mean by this theorem? If we have a triangle ABC, theorem 1 told us that the three medians are concurrent, which means they are meet at one point, which here is G. G is called the point of concurrence. The point G divides the median AD in two parts. The first part AG, which is from the vertex, and the second part is GD, which is the part from the base. When I use this theorem, since G is the point of concurrence of medians of triangle ABC, then DG, which is the part from the base, equals half AG, the part from the vertex. And DG also equals third the whole median. If we consider the median FC, the part CG is the part from vertex, and GF is the part from the base. So FG equals half CG and equal third of FC. If we consider the third median, PE, GE is the part which from the base, and the BG is the part from the vertex. So GE equals half BG and equals third the total median BE. Now we will solve some exercises on theorem 1 and 2. Using the given data for each of the following figures, find the required blue H. 1. We have triangle XYZ. M is the point of concurrence of median. The part MD equals 4 centimeters and YZ equals 10 meters. We want to find length of XM and YD. What about XM? Is it apart from vertex or base? Of course, it is from vertex. So, it is double the part from base. The part from base equals 4. So, XM will equal, excellent, 8. YD. D is a midpoint of YZ. So, YD equals 10 divided 2, which equals 5. In number 2, the triangle is ABC. M is the point of concurrence of median. ME equals 3. CM equals 8. Find MA, MD, ME, MC. First, MA is about from vertex. So, excellent. It is twice about from base. So, MA will equal 6. MD, part from base or vertex? Good job, from base. So, it's half the part from vertex. So, MD will equal 4. ME equals how many AE? ME is the part from base. AE is the total median. So ME equals, very good, third EE. MC is the part from vertex. CD is the whole median. So MC equals, who can say? 2/3 CD. Very good. Another example, ABC is a triangle. M is the point of concurrence of median. BC equals 12. PE equals 9. MC equals 8. We want to find DE, ME, and MD. In first one, DE is the line segment joining two midpoints of two sides of triangle. So it's equal half the third side. So DE will equal half BC. So ED will equal 12 divided 2, which equals 6. ME is a part of median from vertex or from base. Very good, from base. So it will equal third the total median. The total median BE equals 9. So ME will equal, very good, 9 divided 3, which equals 3. MD also is a part from base. So it's equal half the part of from vertex. So MD will equal 8 divided 2, which equals 4. Again in number 4, a triangle XYZ, N is the point of concurrence of median. LZ equals 15, YM equals 18, XY equals 12. First, NL is apart from base or vertex. Very good, from base. So NL equals third the total median. The median LZ equals 15. So NL will equal 5. NY is apart from vertex. So it will equal 2/3 the total median. The total median YM is 18. So NY equals 18 times 2/3. So it will equal 12. The perimeter of triangle NLY is the sum of 3 sides. Now we know the 3 sides. So the perimeter will equal 27. Now another exercise, which is a proof problem. An opposite figure, ABC is a triangle, X is the midpoint of AB, Y is the midpoint of BC, XY equals 5, line segment XC intersection line segment AY equals point M, MC equals 8 and YM equals 3. We want to find the perimeter of triangle MXY and MAC. As we learned how to write proof, we give reason and say since. Then we give the result and say so. Since X and Y are midpoints of AB and BC, the line segment XY joining midpoints of two sides, so it equals half the third side. So XY equals half AC. But I know XY. I want to find AC. So I can write AC equal twice XY. 2 by 5, which equals 10 centimeters. M is the point of concurrence of medians of triangle ABC. So it divides each median in ratio 1 to 2 from base or 2 to 1 from vertex. MX will equal half MC. MC equals 8. So XM will equal 4. MA will equal twice YM. 2 by 3 equals 3, equals 6. The perimeter of triangle MXY is the sum of its 3 sides. So it will equal 4 plus 5 plus 3, which equals 12 centimeters. The perimeter of triangle MAC also is the sum of its 3 sides. So it will equal 6 plus 10 plus 8, which equals 24 centimeters. Now another example. In the opposite figure, ABC is a triangle in which D is a midpoint of BC, E is a midpoint of AC, and AD intersection BE equals point M. If AD equals 6 and AB equals BE equals 9 centimeters, calculate the perimeter of triangle MDE. First, since D and E are midpoints of BC and AC, the length of the line segment joining the two midpoints of two sides of triangle equals half the third side. So DE will equal half AB. AB equals 9. So DE will equal 4.5 centimeters. AD and EP are two medians intersect at M. So M is the point of concurrence of medians of triangle ABC. MD is apart from base equals third the total median. So 6 divided 3 equals 2 centimeters. ME also is about from base will equal serve the total median. EB equals 9, so ME will equal 3. The perimeter of triangle MDE is the sum of the three sides, which will equal 9.5 centimeters.